Hi, this is Cliff Nelson from Redwood Tutoring. I want to conclude my series on logarithms by talking about applications. Now, as a fact, a quantity that is increasing exponentially is going to be given by the following equation. A of t equals a naught times e to the kt. A of t equals a naught, that's how we pronounce this, a naught times e to the kt. Now, a of t is the amount of the quantity at time t. A naught is your initial or your starting amount, and k is the exponential growth rate. Let me go ahead and go through two examples that use this function. In my first example, I want to talk with you about the U.S. population. The population of the United States has been increasing exponentially. I went on Wikipedia to try to grab some numbers to work with, and I was able to come up with the following. For the U.S. population, the exponential growth rate is about 1% per year. And in 2011, there were 313 million people. 313 million Americans. Now, if that's the exponential growth rate, and if this is the population in 2011, I want to see if I could project the population in 2031. So if I'm going to be going 20 years later, I want to see what the population is going to be. Well, I know that the formula is A of t equals, well, what I'm going to have here is the initial population. Well, that's going to be my 313 million. So I'm just going to put 313. And then it's going to be times e raised to the kt. Well, k is 1% per year. It's best if we write that as 0.01. So 0.01 t. So the amount at time t is equal to the amount that I started with, 313 million, times e raised to the 0.01 t. Well, since this is 20 years later, then what I'm interested in here is a of 20, the amount or the population 20 years after I started. So this is going to be 313 times e to the 0.01 times 20. Plugging this into the calculator gives me approximately 382. Since my units are in millions of people, my final answer is that I project that there will be about 382 million Americans in the year 2031. Now, exponential growth is not just dealing with populations of people or animals, but you could also deal with, for instance, revenue growth. And one company that has shown remarkable revenue growth is Apple. I believe that I got this data from Standard & Poor, which keeps track of Apple's revenue. Now, in 2002, Apple's revenue was this amount. The units are in millions of dollars, so this is $5,742,000,000. Now that seems like a lot, but for the fiscal year 2011, their revenue was reported as $108,249 million, or equivalently $108,249 million. Now, all of this took place in 9 years. 9 years. So what I want to do is I want to figure out the annual exponential growth rate k. Find the annual exponential growth rate, which is given by the letter k. Well, I know the formula goes like this. It's A of t is the amount at time t, and then it's going to be equal to the initial amount, so I'm going to have 5,742 times e raised to the kt. So I don't know what k is. That's what I'm trying to solve for. But I do know that 9 years later, a of 9, I know that that's equal to 5,742 times e to the 9k, or k times 9. But I also know that number. It's 108,249. So this part right here gives me an equation to solve for. Well, in order to solve for this, let me just go ahead and rewrite it. 5,742 raised to the times e to the 9k equals 108,249. Now, to solve for k, what I need to do first is to isolate this exponential expression. I need to divide both sides by 5,742. Doing this will allow me to cancel these two numbers, and I have e to the 9k equals 108,249 over 5,742. Dividing both sides by 5,742 gives me e to the 9k equals 108,249 over 5,742. Now, before I do my next step, off to the side, I want to show you the property that I'm using. This goes back to one of our earlier lessons, in which we found out that give me any base b, log base b of b to the x equals x. So in particular, log base e for the number e of e to the x also equals x. All I'm doing is using a specific number rather than a general base b. But you guys know that this right here can also be written as ln. So this same rule is the natural log of e to the x equals x. Now this rule right here is really going to help us out when it comes to solving a problem like this. What I'm going to do is I'm going to take the natural log of both sides. So on the left here I have the natural log of e to the 9k. On the right I have the natural log of 108,249 over 5,742. And then since the natural log of e to the x equals x, this is going to give me on the left-hand side, these things undo each other, and I'm left with just 9k equals the natural log of that expression. If I just multiply both sides by 1/9, these will cancel each other out. Plugging this into my calculator, I'm going to end up with K is approximately equal to 0.326. So in that period of time, Apple has been growing at the remarkable growth rate of 32.6% per year. This is Cliff Nelson. Have a great day.